Hello friends, today I am discussing about the most important chapter of science, class 8, from which minimum 2 to 4 questions are asked in every exam. So it is most important. So let's start without wasting of time. Chapter number is 11. Chapter name is Chemical Effects of Electric Current. So let's start. Okay? Your elders might have cautioned you against touching an electrical appliance with wet hands. But do you know why it is dangerous to touch an electrical appliance with wet hands? What? क्या आप जानते हैं कि आपके जो एल्डर्स होते हैं, जो आपसे बड़े होते हैं, वो आपको हमेशा बताते हैं, समझाते हैं कि कभी भी गीला हाथ से कोई भी इलेक्ट्रिकल अप्लायंस को नहीं छूना चाहिए। तो क्यों नहीं छूना चाहिए, इस चीज़ के बारे में आज हम पढ़ेंगे, समझेंगे इस चैप्टर में। नेक्स्ट, वी हैव लर्नड अर्लियर दैट द materials which allow electric current to pass through them are good conductors of electricity. On the other hand, materials which do not allow electric current to pass through them easily are poor conductor of electricity. जैसा कि हम अर्लियर क्लास में, पिछले क्लास में पढ़े हैं कि वैसा मटेरियल जिसमें इलेक्ट्रिक करंट पास होती है तो उसको हम क्या कहेंगे, गुड कंडक्टर कहेंगे। और वैसा मटेरियल्स जिसमें इलेक्ट्रिक करंट पास होने के लिए अलाउ नहीं मिलता है, डू नॉट अलाउ मतलब अलाउ नहीं करता है, इलेक्ट्रिक करंट पास नहीं होता है, उसको हम क्या करेंगे, पुअर कंडक्टर ऑफ इलेक्ट्रिसिटी। इन क्लास 6 we made a tester to test whether a particular material allow the electric current to pass through it or not. Do you recall how the tester helped us in deciding that what? We found that metals such as copper and aluminum conduct electricity, whereas materials such as rubber ओके गुड कंडक्टर, बैड कंडक्टर या पुअर कंडक्टर। आप देख सकते हो यहाँ फिगर 11.1 में ये टेस्टर है, ये टेस्टर है। ये टेस्टर में ये जो रेड वाला पार्ट है ऊपर वाला, वो बैड कंडक्टर होता है, पुअर कंडक्टर होता है, लेकिन ये जो है गुड कंडक्टर होता है। लेकिन इसके अंदर जो है एक कनेक्शन रहती है। गॉट इट? नेक्स्ट, प्लास्टिक एंड वुड्स डू नॉट कंडक्ट इलेक्ट्रिसिटी। जो प्लास्टिक होते हैं और लकड़ी होते हैं वो कभी भी इलेक्ट्रिसिटी कंडक्ट नहीं कर सकते। हाउएवर, सो फार वी हैव यूज आवर टेस्टर टू टेस्ट मटेरियल्स which were in solid state. But what about liquids? What? Do liquids also conduct electricity? What? Let us find out. Pehli and Bujo want to remind you that one should not experiment with the electric supply from the mains or a generator or an inverter. Use only electric cells for all the activities suggest here. Next, do liquids conduct electricity? What? To test whether a liquid allow electric current to pass through it or not, we can use the same tester, figure 11.1. Got it? However, replace the cell by a battery also before using the tester. We should check whether it is working or not. Activity 11.1. Join the free ends of the tester together for a moment. This complete the circuit of the tester and the bulb should glow. However, if the bulb does not glow, it means that the tester is not working. Can you think of the possible reason? What? Is it possible that the connection are loose? What? Or the bulb is fused? What? Or your cell are used up? What? Check that all the connections are tight. If they are, then replace the bulb with another bulb. Now test if the tester is working or not. If it is still not working, then replace the cells with fresh cells. Next, now that our tester is working, let us use it to test the various liquids. Caution: while checking your tester, do not join its free ends for more than a few seconds. Otherwise, the cells of the battery will drain very quickly. Got it? इसी को ध्यान में रखना है हमेशा. Activity 11.2. Collect a few small plastic or rubber caps of discarded bottles and clean them. Pour 1 teaspoon of lemon juice or vinegar in one cap. Bring your tester over this cap and let the ends of the tester dip into lemon juice or vinegar as shown in figure 11.2. Take care that the ends are not more than 1 centimeter apart, but at the same time do not touch each other. Does the bulb okay of the tester glow? Does lemon juice or vinegar conduct electricity? What? How would you classify lemon juices or vinegar, a good conductor or a poor conductor? Figure 11.2. Testing conduction of electricity in lemon juice or vinegar. Here is a lemon juice. Got it? When the liquid between the two ends of the tester allow the electric current to pass, the circuit of the tester becomes complete. The current flow in the circuit and the bulb glow. When the liquid does not allow the electric current to pass, the circuit of the tester is not complete and the bulb does not glow. Got it? Next, in some situation, even though the liquid is conducting, the bulb may not glow. It may have happened in activity 11.2. What can be the reason? What? Do you remember why the bulb glow when the electric current passes through it? What? Due to the heating effect of current, the filament of the bulb gets heated to a high temperature and it starts glowing. However, if the current through a circuit is too weak, the filament does not get heated sufficiently and it does not glow. And why is the current in the circuit weak? Well, through a material may conduct electricity. It may not conduct it as easily as a metal. As a result, the circuit of the tester may be complete and yet the current through it may be too weak to make the bulb Glow can we make another tester which can detect a weak current. Got it? We can use another effect of an electric current to make another kind of tester. Do you recall that electric current produces a magnetic effect? What happens to a compass needle kept nearby when current flow in a wire? Even if the current is small, the deflection of the magnetic needle can be seen. Can we make a tester using the magnetic effect of currents? Let us find out in activity 11.3. You may use an LED figure 11.3 in place of the electric bulb. In the tester of figure 11.2, LED glow even when a weak electric current flow through it. Got it? Next, there are two wires called LEDs attached to an LED. One LED is slightly longer than the other. Remember that while connecting to a circuit, the longer LED is always connected to the positive terminal of the battery and the shorter LED is connected to the negative terminal of the battery. Got it? फिगर 11.3 लेड्स. यहाँ पे ये जो छोटा वाला है इसको नेगेटिव पॉइंट से कनेक्ट करना है और ये जो बड़ा वाला है इसको किससे करना है? पॉजिटिव पॉइंट से. इसी को ध्यान रखना है. गॉट इट? एक्टिविटी 11.3. टेक द ट्रे फ्रॉम inside a discarded matchbox. Wrap an electric wire a few times around the tray. Place a small compass needle inside it. Now connect one free end of the wire to the terminal of a battery. Leave the other end free. Take another piece of wire and connect it to the other terminal of the battery. Figure 11.4. Figure 11.4 another tester. Join the free ends of two wires momentarily. The compass needle should show deflection. Your tester with two free ends of the wire is ready. Now repeat activity 11.2 using this tester. Do you find a deflection in the compass needle the moment you dip the free ends of the tester in lemon juice? Next, take out the ends of the tester from the lemon juice. Dip them in water and then wipe them dry. Repeat the activity with other liquids such as tap water, vegetable oil, milk, honey. Remember to wash and wipe dry the ends of tester after testing each liquid. In each case, observe whether the magnetic needle show deflection or not. Record your observation in table 11.1. Here, table 11.1, good or poor conducting liquid. Material, compass needle show deflection, yes or no. Good conductor, poor conductor. Lemon juice is a compass needle show deflection, yes or no? Yes, it is a good conductor. Similarly, ये जो सभी हैं इस सब को भी फिल करना है. गॉट इट? From table 11.1 we find that some liquids are good conductor of electricity and some are poor conductors. Got it? Next, when the free ends of the tester do not touch each other, there is an air gap between them. Pehli knows that air is a poor conductor of electricity, but she has also read that during lightning an electric current passes through air. She wonders if air is indeed a poor conductor under all conditions. This makes Bujo ask whether other materials classified as poor conductors also allow electricity to pass under certain conditions. Actually, under certain conditions, most materials can conduct. That is why it is preferable to classify materials as good conductors and poor conductors instead of classifying as conductors and insulators. We have tested the conduction of electricity through tap water. Let us now test the conduction of electricity through distilled water. Activity 11.4. Take about 2 tablespoonfuls of distilled water in a clean and dry plastic or rubber cap of a bottle. You may obtain distilled water from your school science lab. You may also get distilled water from a medical store or a doctor or a nurse. Use the tester to test whether distilled water conduct electricity or not. What do you find? What? Does distilled water conduct electricity? What? No. Dissolve a pinch of common salt in distilled water. Again test. What do you conduct? And conclude this time. When salt is dissolved in distilled water, we obtain salt solution. This is a conductor of electricity. यदि आप डिस्टिल वाटर में आप इलेक्ट्रिसिटी पास करवाना चाहोगे तो उसमें इलेक्ट्रिसिटी पास नहीं होगा, वो बैड कंडक्टर एज अ बैड कंडक्टर शो करेगा. गॉट इट? लेकिन यदि आप डिस्टिल वाटर में कुछ साल्ट सॉल्यूशन मतलब साल्ट सॉल्यूशन बना लेते हो, उसमें कुछ साल्ट डालते हो तो वो साल्ट सॉल्यूशन हो जाता है और उससे इलेक्ट्रिसिटी कंडक्ट होना शुरू हो जाती है. गॉट इट? डिस्टिल वाटर जो होता है प्योर वाटर होता है और इसमें नमक की मात्रा नहीं होती है और इसमें इलेक्ट्रिसिटी पास नहीं हो सकती है. लेकिन जो भी टैप वाटर होते हैं या समुद्र के पानी होते हैं या पॉन्ड के होते हैं, इसमें थोड़ा बहुत मात्रा में नमक रहता है, तो इसलिए इससे इलेक्ट्रिसिटी जो है इजी वे में पास कर जाती है. गॉट इट? नेक्स्ट, द वाटर दैट वी गेट फ्रॉम सोर्सेस सच एज टैप्स, हैंड पम्प्स, वेल्स एंड ponds is not pure. It may contain several salts dissolved in it. Small amounts of minerals salt are naturally present in it. This water is thus good conductor of electricity. On the other hand, distilled water is free of salts and is a poor conductor. समझ गए? जो डिस्टिल वाटर होते हैं वो फ्री होते हैं किससे? साल्ट से, और इसलिए यह पोअर कंडक्टर होते हैं इलेक्ट्रिसिटी के. गॉट इट? नेक्स्ट, ए स्मॉल अमाउंट ऑफ मिनरल साल्ट्स present naturally in water are beneficial for human health. However, These salts make water a good conductor. So we should never handle electrical appliance with wet hand or while standing on a wet floor. Got it? Next, we have found that common salt, when dissolved in distilled water, makes it a good conductor. What are the other substances which, when dissolved in distilled water, make it conducting what? Let us find out. Kasan, do the text. Kasan, do the next activity under the supervision of teacher, parent or some elderly person, because the use of acid is involved in it. Got it? Here activity 11.5. Take 3 clean plastic or rubber caps of bottles. Pour about 2 spoonfuls of distilled water in each of them. Add a few drops of lemon juice or dilute hydrochloric acid to distilled water in one cap. Now, in the second cap containing distilled water, add a few drops of a base such as caustic soda or potassium iodide. Add a little sugar to the distilled water in the third cap and dissolve it. Test which solutions conduct electricity and which do not. What result do you obtain? What? Most liquids that conduct electricity are solutions of acids, bases and salts. When an electric current go through a conducting solution, does it produce an effect on the solution? What? 11.2 Chemical effect of electric current. In class 7, we have learned some effect of electric current. Can you list these effects? What effect does the current produce when it flows through a conducting solution? Let us find out. Activity 11.6. Take out carbon rods carefully from 2 discarded cells. Clean their metal caps with sandpaper. Wrap copper wires around the metal caps of the carbon rods and join them to a battery. Figure 11.5. We call these 2 rods electrodes instead of. Got it? Here figure 11.5, passing current through water. This is a carbon rod. ये क्या है? मेटल कैप. ये क्या है? कार्बन रॉड. ये क्या है? वाटर. गॉट इट? इसको ध्यान रखना है. कार्बन रॉड्स you may take 2 iron nails about 6 cm long. Pour a cup full of water in a glass plastic bowl. Add a teaspoonful of salt or a few drops of lemon juice to water to make it more conducting. Now immerse the electrodes in this solution. Make sure that the metal caps of the carbon rods are outside the water. Wait for 3 to 4 minutes. Observe the electrodes carefully. Do you notice any gas bubbles near the electrodes? What? Can we call the change taking place in the solution a chemical change? What? Recall the definition of a chemical change that you learned in class 7. In 1800, a British chemist विलियम निकोलसन 1753 to 1815 had shown that if electrodes were immersed in water and a current was passed, bubbles of oxygen and hydrogen were produced. Oxygen bubbles formed on the electrode connected to the positive terminal of the battery and hydrogen bubbles formed on the other electrode. इसी को ध्यान रखना है. गॉट इट. यहाँ से क्वेश्चन बन सकता है. In 1800, a British chemist William Nicholson 1753 to 1815 had shown that if electrodes were immersed in water, जब electrodes को वाटर में पानी में इमर्ज किया जाता है, डुबोया जाता है, and a current was passed, और करंट पास किया जाता है, bubbles of oxygen and hydrogen were produced. तो वहाँ पे क्या होता है, बबल्स प्रोड्यूस्ड होता है, बबल्स ऑफ ऑक्सीजन, ऑक्सीजन का बबल्स प्रोड्यूस होता है, एंड हाइड्रोजन वेयर प्रोड्यूस्ड, और हाइड्रोजन का बबल्स प्रोड्यूस होता है. गॉट इट. ऑक्सीजन बबल्स फॉर्म्ड ऑन द इलेक्ट्रोड, जो ऑक्सीजन का बबल होते हैं वो कहाँ फॉर्म्ड होते हैं, इलेक्ट्रोड पे, कनेक्टेड टू द पॉजिटिव टर्मिनल, और कनेक्ट किससे रहते हैं, पॉजिटिव टर्मिनल से, ऑफ द बैटरी, बैटरी के, एंड हाइड्रोजन बबल्स फॉर्म्ड, जो हाइड्रोजन बबल होते हैं वो फॉर्म्ड होते हैं कहाँ पे, ऑन द अदर इलेक्ट्रोड, जो और इलेक्ट्रोड होते हैं उस पर फॉर्म होते हैं हाइड्रोजन. गॉट इट. हाइड्रोजन बबल. तो इस चीज़ को ध्यान रखना है. गॉट इट. नेक्स्ट, द पैसेज ऑफ एन इलेक्ट्रिक करंट थ्रू अ कंडक्टिंग सॉल्यूशन कॉजेज केमिकल रिएक्शंस. As a result, bubbles of a gas may be formed on the electrodes. Deposits of metal may be seen on electrodes. Change of color of solution may occur. The reaction would depend on what solution and electrodes are used. These are some of the chemical effect of the electric current. Got it? Bujo decided to test whether some fruits and vegetables also conduct electricity or not. He cut a potato into two halves and inserted the copper wires of a tester into it. Just then his mother called him and he forgot to take out the wires of the tester inserted into the potato. When he came back after half an hour, he noticed that there was a greenish blue spot on the potato around one wire, whereas there was no such spot around the other wire. Got it? Figure 11.6 टेस्टिंग पोटैटो. ये बुझो नाम की जो लड़की है वो चेक करना चाहती है कि क्या पोटैटो जो होते हैं, आलू जो होते हैं, उससे इलेक्ट्रिसिटी जो है पास हो सकती है या नहीं. गॉट इट. तो इस चीज़ के बारे में ये टेस्ट करना चाहती है. तो टेस्ट की तो ये रिजल्ट देखने को मिला कि एक साइड क्या हुआ, कलर चेंज हो गया, और एक साइड क्या हुआ, कलर चेंज नहीं हुआ. जहाँ पे उसका पॉइंट था, पॉजिटिव टर्मिनल और नेगेटिव टर्मिनल था. ही वॉज सरप्राइज्ड विद दिस ऑब्जर्वेशन एंड along with Paheli repeated this activity many times. They found that it was always the wire connected to the positive terminal which had a greenish blue spot around it. तो उसने देखा और पाया क्या, जो पॉजिटिव टर्मिनल के वायर थे और कनेक्ट किया जाता था पोटैटो पे, वहाँ पे हमेशा क्या होता था, ग्रीन कलर के ब्लू स्पॉट वहाँ पे हो जाते थे पोटैटो पे. They felt that this discovery was very useful because it could be used for identifying the positive terminal of a cell or a battery concealed in a box. They decide to report their finding to a children is magazine. Remember that. Bujo set out to test whether potato conducted electricity or not. What he found was that current produced a chemical effect in the potato. To him, this was very exciting. In fact, this is how science sometimes works. You are looking for something and you discover something else. Many important discoveries have been made in this manner. Got it? Now we will discuss about electroplating. You know that a brand new bicycle has shiny handlebar and wheel rims. However, if these are accidentally scratched, the shiny coating comes off, revealing a not so shiny surface beneath. You might have also seen women using ornaments which appear to be made of gold. However, with repeated use, the gold coating wears off, revealing silver or some other metal beneath. In both these cases, a metal has a coating of another metal. Do you wonder how a layer of one metal can be deposited on top of another? What? Well, let us try doing it ourselves. Got it? Now we will discuss about activity 11.7. We will need copper sulfate and 2 copper plates of size around 10 cm into 4 cm. Take 250 ml of distilled water in a clean and dry beaker. Dissolve 2 teaspoonfuls of copper sulfate in it. Add few drops of dilute sulfuric acid to copper sulfate solution to make it more conducting. Clean copper plates with sandpaper. Now rinse them with water and dry them. Connect the copper plates to the terminals of a battery and immerse them in copper sulfate solution. Figure 11.7. Got it? Here, figure 11.7, a simple circuit showing electroplating. Copper plate, got it? Copper sulfate solution. Yeah. Okay. Allow the current to pass for about 15 minutes. Now remove the electrodes from the solution and look at them carefully. Do you find any difference in any one of them? What? Do you find a coating over it? What? What color is the coating? What? Not done. The terminal of the battery with which this electrode is connected. After doing the electroplating activity, Paheli interchanged the electrodes and repeated the activity. What do you think she would observe this time? Okay. Next point. When electric current is passed through the copper sulfate solution, copper sulfate dissociates into copper and sulfate. Copper sulfate dissociates into copper and sulfate. Got it? The free copper gets drawn to the electrode connected to the negative terminal of the battery and gets deposited on it. But what about the loss of copper from the solution? What? From the other electrode, a copper plate and equal amount of copper gets dissolved in the solution. Thus, the loss of copper from the solution is restored and the process continue. This means that copper gets transferred from one electrode to the other. Bujo could get only one copper plate, so he performed activity 11.7 by connecting a carbon rod in place of the copper plate, which was connected to the negative terminal of the battery. He succeeded in obtaining a coating of copper on carbon rod. This process of depositing a layer of any desired metal on another material by means of electricity is called electroplating. It is one of the most common applications of chemical effect of electric current. Now we will discuss about what? Now we will discuss about electroplating is a very useful process. Got it? Electroplating is a very useful process. It is widely used in industry for coating metal objects with a thin layer of a different metal. Figure 11.8. The layer of metal deposited has some desired property which the metal of the object lacks. For example, chromium plating is done on many objects such as car parts, bath taps, kitchen gas burners, bicycle handlebars, wheel rims, and many others. Next, chromium has a shiny appearance. It does not corrode. It resists scratch. However, chromium is expensive and it may not be economical to make the whole object out of chromium. So the object is made from a cheaper metal and only a coating of chromium over it is deposited. Jewelry makes electroplate. Got it? Now we will discuss about what you have learned. First foremost, we will discuss about figure 11.8 some electrode plated objects. Got it? Next, silver and gold on less expensive metals. These ornaments have the appearance of silver or gold but are much less expensive. Next, tin cans used for storing food are made by electroplating tin onto iron. Tin is less reactive than iron. Thus, food does not come into contact with iron and protected from getting spoiled. Got it? Next, iron is used in bridges and automobiles to provide strength. However, iron tends to corrode and rust. So a coating of zinc is deposited on iron to protect it from corrosion and formation of rust. Next, in the electroplating factories, the disposal of the used conducting solution is a major concern. It is a polluting waste and there are specific disposal guidelines to protect the environment. Got it? Now we will discuss about what you have learned. Some liquids are good conductor of electricity and some are poor conductors. Next, most liquid that conduct electricity are solution of acids, bases and salts. Next, the passage of an electric current through a conducting liquid causes chemical reaction. The resulting effect are called chemical effect of current. Next or last, the process of depositing a layer of any desired metal on another material by means of electricity is called electroplating. Here is some keywords you can go through itself. So thank you friends. Hope you will learn something new. Thank you for watching this video. Hope you will learn something new. Thank you so much. Radhe Radhe.